All right. Here, we're going to get some experimental data, and we need to determine what the rate law is. This is molarity. So this should be molarity per second. Working on that. Okay. So I'm going to number my reactions 1, 2, and 3. And the first one I want to work on is S2O8. So we have to take each one of these individually. So I need 2 reactions where S2O8 is changing and I minus is staying constant. And for me, those are going to be rate 1 and rate 2. So I always write what I'm doing. K times S2O8 in reaction 2 to the N for K, that looks like an R, but it's a K. S2O8 to the N in reaction 1. K's will cancel out. So in rate 2, 6.65, these units will cancel, so you don't have to put them on there. 4.54 and 0.44, 0.3. These are the same power, so they're to the N. So let's see what we get. We get 1.46. And 1.47. Hopefully we can agree that this is a first order reaction, because these are really close. If you don't know, take the log of both sides. So take log 1.46 and divide it by the log of 1.47. And round. We want these to be a whole number. Okay, now let's look at our second one. Here we're investigating the I minus. So we want 2 reactions where the concentration of iodine is changing and the concentration of S2O8 is staying the same. So it looks like for me that's going to be reaction 2 and reaction 3. I don't like fractions, so I'm going to say reaction 2 goes on top and reaction 3 goes on the bottom. Again, that doesn't matter which way you do it. That's going to be K times I minus reaction 2 to the N, K I minus reaction 3 to the N. This just helps me plug and chug correctly. Rate 2, 6.65, 3.33. K's cancel out. Iodine here is 0.42, 0.21, and all that's going to be to the N power. Some of you are probably going, well, that's really close. You can do a lot of this in your head. And if that's you, awesome. Okay, and to the N. So that is also a first order. Okay, so our generic rate law is going to be rate equals K S2O8 minus 2 to the first and I minus to the first. Or you don't have to put the coefficients on there. It's understood. Okay, but we want to find the value of K now. So let us pick a reaction. And I'm just going to use reaction 1. Now, when we're doing this, we must put our units on. So the rate is 4.54 molarity per second. K is what we're solving for. 0.3 molar to the first power. 0.42 molar to the first power. Okay, so 0.3 times 0.42. So that gives me 4.54 molarity per second. K, 0.126, and that's molarity squared. So be careful here. Put the units in. So now we need 4.54 divided by that. So that gives me K equals 36. And so we got to divide by 0.126 molarity squared. So that cancels out and leaves me with a molarity in the bottom and a seconds in the bottom. So that can be kind of confusing, so just be careful there. So here's our generic rate law, and here's our value of K.